Using this diagram in one of our previous videos, we were able to derive the resultant of two vectors A and B, and also to obtain an expression for the angle between vector A and the resultant vector. Our result was R equal to, we obtained the magnitude of the resultant vector R as the square root of A squared plus B squared plus 2AB cos theta. Then we also obtained phi equal to arctan or tan inverse of B sin theta divided by A plus B cos theta. So if you want to learn more about how we derive these two expressions, you can check the description of this video for the link to that particular video. In this video, we will solve some examples on the triangle law of vector addition. So we'll start with the first example, example 1. The first example is to find the magnitude the magnitude the magnitude find the magnitude of the vector A given that magnitude of vector B magnitude of vector B and resultant vector R is 4 and 6 units respectively. The angle between the two vectors is 60 degrees. Between the two vectors is 60 degrees. So this is the problem that we will solve. Solution. According to the triangle law of vector addition, the magnitude of r is given by r squared equal to a squared plus b squared plus 2ab cos theta. So here we have r is equal to 6, a is unknown, b is equal to 4, and theta is equal to 60 degrees. So we need to find a. We will put the above values in this formula above to have 6 squared is equal to a squared plus 4 squared plus 2 times a times 4 times cos 60 degrees. So 6 squared is equal to 36. So 36 is equal to a squared plus 16 plus 2 times 4 is 8 times a. We have 8a cos 60 degrees. So 36 minus 16 will be on the left side. 36 minus 16 is equal to a squared plus 8a cos 60 degrees is half. So this gives us 20 on the left side equal to a squared plus 4a. 8 is divided by 2 to give 4. So we can rearrange this to have a squared plus 4a minus 20 is equal to 0. So you can see that this is a quadratic equation which we can easily solve by the quadratic formula. So in case you don't recall the quadratic formula, we have minus b. The quadratic formula is minus b plus or minus square root of b squared minus 4ac all divided by 2a. So in this case, here a is the coefficient of this, and that's equal to 1. B is 4 and C is minus 20. So we'll solve this quadratic equation using this quadratic formula. So this will be equal to A is equal to minus 4 plus or minus square root of 4 squared minus 4 times 1 times minus 20 divided by 2 times 1. So we will have A equal to minus 4 plus or minus square root of 16 minus times minus gives us a plus, so this will change to plus. 16 plus 4 times 1 times 20, we have 80, all divided by 2. So simplifying further, we have A is equal to minus 4 plus or minus root 16 plus 80 is 96, all divided by 2. So we can write this as minus 4 plus or minus root 16 multiplied by 6, all divided by 2. So this is equal to minus 4 plus or minus root 16 is 4, so we have 4 root 6 divided by 2. So this is equal to minus 2 plus or minus 2 root 6. Here we divided through by the denominator 2. So that's why we have minus 2 plus or minus 2 root 6. Since the magnitude cannot be negative, we take the positive roots. So we are going to have A is equal to minus 2 plus 2 root 6. And we have minus 2 plus 2 by 2.4495. That's the root of 6. Then if we multiply out, we will have minus 2 plus 4.899. So this is equal to minus 2 plus 4.899 is equal to 2.899. Therefore, the magnitude of vector A is approximately equal to 2.9 units. All right, now we can go to the second example. Example 2. Find the magnitude Find the magnitude of vector A if the magnitude if the magnitude of vector B is 10 units. And the angle between the two vectors is 60 degrees, while the angle between vector A and the resultant is 45 degrees. So here we need to find the magnitude of a vector A given the magnitude of another vector B, which is of 10 units, and the angle between the two vectors is 60 degrees, while the angle between vector A and the resultant vector is 45 degrees. Solution. From the triangle law of vector addition, the angle phi is given by arctan b sine theta divided by a plus b cos theta. So tan phi will be equal to b sine theta over a plus b cos theta. Here we already have the magnitude of a vector B as 10 units. The angle theta is equal to 60 degrees and the angle phi is equal to 45 degrees. So putting these values in this formula, we will get tan 45 degrees is equal to 10 sine 60 degrees divided by a plus 10 cos 60 degrees. We need to find a. Tan 45 degrees is equal to 1. So we write 1 on the left hand side. Then on the right hand side we have 10 into sine 60 is equal to root 3 over 2. We have 10 into root 3 over 2 all divided by a plus 10 into cos 60 is half, So we have half here. So if we multiply out, we will have 10 divided by 2 gives 5. So we have 5 root 3 divided by a plus 5. Half of 10 is 5. So if we cross multiply, we will have a plus 5 is equal to 5 root 3. A plus 5 is equal to 5 root 3. A is equal to 5 root 3 minus 5. So this is equal to 5 into root 3 minus 1. Since 5 is common to this term and this. So this is going to be equal to 5 into the value of root 3 is 1.7321 minus 1. So that's equal to 5 times 0.7321. So if we multiply out, we will have A is equal to 3.6605. So approximately the magnitude of vector A is equal to 3.7 units. 3.7 units. Thank you for watching this video. Please, if you have any questions, feel free to leave them in the comments section. And don't forget to like and share, and also subscribe to this channel.